Hi, I'm Justin Kelly from 3DB Labs, and this is hopefully the first of many videos on our Sceptre software and how you can use Sceptre. And for the first video, it seemed fitting to have a brief overview of what you can do in Sceptre and what it looks like and how it feels. Subsequent videos will describe more in depth on how to use many of the things that I'll gloss over. So for a brief description as to what is Sceptre, Sceptre is a deployable, remotable RF collection software suite that can act alone or as a network of receivers to perform rapid signal ID, tipping queue, and geolocation. It can be integrated with multiple simultaneous different receivers on stationary or mobile collection platforms and provides real-time analysis of comms and radar signals. It performs real-time demodulation of signals, can do real-time bit breakout of those signals, data stream out into other applications, and pulse descriptor word creation for pulse signal analysis. The versatile nature of Sceptre allows a user to leave it unattended for theoretically days. There's a circular FIFO buffer inside of Sceptre that, should you have the storage capacity to support it, you could just let it run indefinitely until that storage buffer fills up and then begins to roll off. Then you can go back in time, place a tuner, do an extraction of raw pre-D, the area that you're interested in, save it off and recall for analysis later. So it makes it pretty ideal for remote access or RF surveys or post-event analysis, whether using the native GUI, which we'll discuss mostly today, or the remote web interface, which is accessible through HTML. So this is the default display for Sceptre, and depending on which operating system you're using, it will look slightly different depending if you're using Windows or Mac or Linux. But generically, it's the same. In addition to that, on the left-hand side are all of the RF inputs you can select. And again, depending on your operating system, primarily dictated by whether you're using Linux or not, you will see more or less options there. There are several receivers that we interface to where we were provided a binary driver compiled to Linux, so it only works on those operating systems. Then on the right-hand side are previously saved configurations that can be recalled, and you can highlight over those. We'll show you a brief description of what it was doing, and you can right-click on that and edit it. The topmost always being the previous session, which is saved once a second. So for this demonstration, I'm going to be using a Edis B200 Mini as my receiver, and hopefully as I continue these, I'll use a variety of different receivers on a variety of different operating systems to further demonstrate the different options that you have as a user. So when you click on the selection you want or the receiver you want, you're presented with a few generic options here, most of them having to do with the connection. The B200 Mini, for those that aren't familiar with it, is a USB device, so needing to input an IP address isn't necessary. So for those receivers that are in a family, such as the USERP, from here you would select the device type. Like I said, I'm using the B200 mini here, so that falls under that category. The other options are the X300, or if you are using an E series or N series, you would input generic, and then we use the US or the USERP interface to connect to those. Also, if you have an internal external PPS that you want to use, you would select that here, or if you have an internal GPSDO. Now the B200 Mini only has the option for a 10 meg ref and does not have the ability to have either an internal GPSDO or an external 1 PPS. So I'll just leave those as internal for right now. And then lastly, depending on the receiver, if you have different daughter boards that you want to map specifically, you can do that here as well. After clicking next, you're presented with a few other options. Other videos will go into these a bit more, such as launching the remote web interface, the circular FIFO buffer, which I'll refer to from now on as the DVR mode, and then some other generic default settings, which we'll discuss further at another time. The first time you load a device from, which is a USERP, it does have to load the image onto that device, so it does take a little bit of time to load that image, but then it's fairly straightforward after that. So this is the default appearance for any device launched from SCEPTRE. You have your spectrogram, all very generic. Your system statistics, so letting you know how your CPU is doing, your current disk usage. If you're reading from disk, say a file, or if you're writing to disk, you'll see here that is ticking up about once a second, which corresponds to the writing of the previous configuration I mentioned earlier. The reason behind that, should your computer lock up or you have a hardware problem, you're not stuck in the dark. You can quickly react and respawn what you were doing. Then generically, your current tune frequency, some gain settings. For example, I'll raise this up right now just a little bit. Maybe go a little bit lower. Some things also to be aware of before we discuss the receiver I'm using, or SCEPTRE for that matter. The B200 Mini, although great for the price, does not have a pre-selector and has a square wave for its LO. So when you're tuned to 100 megahertz, if you see my Wi-Fi signal coming in here, you'll know why. Okay. So if I want to, we'll just at a higher level go over some of these things that you can see here and some of the UI. You'll see that my cursor turns into a hand right here. I can click that, or left click, and move that up, which corresponds or changing the dynamic range or of the spectrogram. I can mouse wheel over that, zoom in, likewise. And I can change the color bar independently as well. And if I want it to auto scale, if I click this button up here to auto scale, it will try to fit all the data into one display. Okay. Earlier you saw me click this button. This is another setting that we'll get into later, but how many software tuners you want displayed by default. Right now, these are just 2 software tuners, and we'll get into what you can do with those at another time. You can see I can left click here, move those, mouse wheel to change the bandwidth on them. Okay, so to control scepter from a high level, it's best to think of it in a tree. So if you click Window, you'll see various options: full screen, add a workstation. You can see here now I can toggle back and forth if I'm running out of space. Analog tuner, so you can hook up a analog tuner and into a digitizer receiver or just a digitizer card. For some that have a digital to analog capability, you can control it there. The B200 Mini being one of those. A debug mode, testing for GPS coherency, general information on the data streams being created by SCEPTRE. Some other interfaces here. Live stream to pipe data out into another application. Location information if you are hooked up to a GPS receiver. Map display to view geolocations or demodulated signals that have their position in them, such as AIS or ADSB. Recorders to manually in a more one-stop shop configure all of the recordings that you're going to do. Recording database to look at all the files you've looked at and gives you the other option to convert those. Oh, you can see my Wi-Fi popping in there at 100 megahertz. Session tags, which I didn't discuss, but if you want to create a session tag, what will happen is every single file you'll create will be tagged with that, so you can filter those out in the recording database. Stream calibration to calibrate time and power. System monitoring. System monitoring is essentially the same as system statistics, with the one exception that if you are using GPU-based processing or you're concerned about the internal temperature of the radio, should that information be available to us, you can plot all that information as well. But for a B200, it's no different than system statistics. Okay. So for each receiver, depending on how many channels there are, you'll have a number of inputs. Input 1 being channel 1, channel 2, et cetera, et cetera. You'd have as many inputs as you would for channels. And then you have a variety of options to launch. You have the control panel, scanner to set up a scan file. So if you wanted your receiver to tune from 100 to 200 megahertz in 20 meg steps, and then sit on 3 gigahertz and then repeat, you can set that up there. Spectrum spectrogram, which are already up. IQ plot, DMOD. These are your sort of lower level DMODs, AM, FM, PM DMODs. And then for each DMOD, you can bring up a spectrum, spectrogram, oscope, oscillogram, the audio, do an autocorrelation function, and spectrum band power. Same is true for linear DMODs. So you can do symbol decisions, IQ plots off of that as well. Equalizer taps. You can do nonlinear DMODs, and again, spawn, spectrum, spectrogram, IQ plots, do an autocorrelation from a nonlinear DMOD. Pulse analyzer, which we'll get into a bit more in another video. But from here, you can determine what algorithm you want SCEPTRE to use to detect pulses, as well as plotting all of that pulse information in a display that makes sense. ACARS data, AIS data, ATSC DMOD. So if you wanted to demodulate digital video, you can demodulate digital video here and view it. Auto detect spectrum. So you can set up a static plot of your RF environment, create a snapshot of the spectrum, and then have that be your reference. And then should anything break threshold, X amount of dB, Above that, you can have the system automatically place a software tuner there and do a recording. An autocorrelation function again on the whole data. A fur filter, so if you want real-time compression or sequence or LF, that's frequency modulation on the pulse, you can do that there. FAD mods, mode AC, mode S. If you need to calibrate, you can calibrate off of a reference. Sample bit, histogram, sample saturation, which I highly encourage to always have up. It's a great indicator to know how you're doing and are you close to clipping. It's in dB below saturation, so you can see you want to maintain something in between -12 and -6 dB just to give yourself a little bit of breathing room there. Swept tune, which we'll go over in another video, but that essentially is sweeping your receiver as fast as humanly possible, or as fast as mechanically possible, and then stitching that environment together and creating a giant spectrum and spectrogram of that environment. UAT data, and then channel 1, channel 2, which if you recall back to the software tuners that I have here, that is what those correspond to. And if I just hover over them, you'll see that this entire tree here is repeated under this. So I can do all of these operations either on the whole source or on a software tuner. So for example, channel 1, I can launch a spectrum. And you can see there's my spectrum. I can make that a bit wider. Can move it around too in here. I can wheel around and make it wider here as well. And obviously this is FM radio. And for every plot that you actually display in SCEPTRE, there's a little cog here which gives you enhanced options. So if I tick this little cog, you'll see it's brought me up the settings. And this is a good way to demonstrate how the UI kind of looks and feels. It's very customizable, and you can grab onto this and move it around, and you can see it's trying to dock it. In addition, if I want to, you can actually put it on top of another one, and you can see that it's tabbed it. If I want to pull it off, pull it off. And I can also detach it. And now it's not detached anymore. There's also some other options here as well. So I can turn the audio on for that signal. Now this is FM radio. So by default, the audio coming out is AM modulated. So I can turn that on. You may or may not hear it. Looks like I'm talking through my earphones. So let's give that one more try. Well, I'll try to get that squared away another time so that you can actually hear it. Right now it's playing through my earphones so that this screen capture can go through my Bluetooth headsets. But I can also change that here and say I want it to play out an FMD mod instead, which would allow me to actually hear that properly. And I can rearrange those and move them up and down. I can also, like I said, on Workspace 2, do the same thing. So this is channel 2. Can make that wider and wider. Move that over. If I dive down here a bit more, drag that up, launch my options. There are a couple other higher level things you can do as well. So if you want to change the amount of time that is displayed in here, take this to fixed time and change it to 20 seconds or whatever you want. By default, it wraps around, but I personally prefer a waterfall plot. How you want the FFTs to look, the compression mode, max, min, or average. Another neat trick here is if I tick on the spectrum tab, if I view the FFTs, currently I have a 4K FFT size. Let's make that 16K. And what's interesting is if I tick the zoom FFT button here, well, that's going to do, well, let's see what it does without it first so you can see. If I zoom in, it's not enhancing, it's keeping the same resolution bandwidth. But if I change zoom FFT on, as I zoom in, every time I zoom in, it will have 16K FFT for that new zoom box. So if I zoom in, you'll see that my resolution bandwidth went to 11.92 hertz. If I zoom in again, you'll see it went to 1.49 hertz. So this can be a fairly useful application. The amount of coverage you want, so we don't gap sample, that's 100% coverage. Amount of overlap, frames to average, etc., etc. Okay, so this has just been a very, very high level overview of Sceptre and how it looks and how it feels. In subsequent videos, we'll go over a bit more in depth on how to, say, use the built-in signal generator or do pulse plotting, pulse analysis, linear demods, bit breakout, setting up a DVR file, and I'll see if I can find some way to pipe the audio through my computer and my headsets as well. Okay.